I would like to talk about the Sieve of Eratosthenes. Firstly, I will go through an example, and then we can look at the pseudocode. Firstly, we try to traverse this sequence, and let's say we try to find out the prime number no larger than 20. So if we try to traverse that sequence, we only need to traverse from 2 to the lower bound of square 20, all right, which is 4. Which means we only need to go through 2, 3, 4 as our starting point. Then what we do is we cross over all multiples of 2, starting from 2 to the power of 2 squared, starting from 2 squared. All right, so we cross over 4, and then we cross over 2 squared plus 2, which is we cross over 6, and then we cross over 8, which is 2 squared plus 2 plus 2 again. All right, so as you can see, we are deleting all the even numbers. And then when we reach the end of the point, we just start over again. Since we have already done the first letter, then we just start from 3. And here is a crucial point you have to pay attention to, and this is why I'm doing this, because I have seen so many algorithms which are not optimized. All right, look at what I will do. What I will do is I will cross over from 3 to the power of 2 first, which is 9. So I will cross 9. All right, and then I can cross 9 plus 3, which is 12, which is already been deleted, and plus 3 again, which is 15. All right, and 18. And when I try to cross over 21, it already exceeds the boundary. So then we come back. And the difference between my video and other video is that I start from the power of that number. Instead of many video only talk about you will start with all the multiple of that number, which means, for example, the number 6, all right, as we can see, we have already crossed 6 when we start with number 2, since 6 is the multiple of 2. In fact, 6 is 2 to the power 2 plus 2. And I have seen so many videos doing this. They will say, okay, cross over all the multiples of 3, which means you will cross 3 multiplied by 2, which is 6. All right, then cross 6, but which has already duplicated what 2 have already done. Because if you look at this, 3 to the power of 2 plus 3, all right, I will write it again, 3 to the power of 2 plus 3 would equal to 3 multiplied by 3 plus 1. All right, that will be 3 multiplied 4, isn't it? So as you can see, by plus 3 to that number, we're actually deleting every multiple of 3. But however, you should be patient, pay attention that we are not dealing with 3 multiplied any number smaller than it, for example 2, because it is wrong, since we have, no, it's not wrong, but it's not optimized since we have done it before. I mean, at this point, it may not be obvious how much time we are saving, but imagine this is a long list to, I don't know, maybe 100,000. And then the number, and there is number you try to start as like, so for example, you are trying to do is the number 1000 and try to delete every multiple of 1000, which you should, let's add one more 0 here. At this point, you just need to do a multiple, 1000 to the power of 2 to reach the over boundary, which means this is the end of the list you try to traverse. And you should not try to multiply this number by 2 or by 3 or by 5 to delete all the multiple of 1000, because we have done that so many times. Anyway, yeah. And back to the list, after we deleting multiple of 3, we try, okay. And then when we look at 4, which is already been deleted, so that's fine. And we are not going to 5 because, as we said before, we only go through 2 to the lower boundary of 20, which is 4. So whatever is left in the list is a prime number, as we can see. 2, 3, 5, 7, 11, 13, 17, 19. All right. So the key point here is we're starting with 2 to the power of 2, 3 to the power of 2, whatever to the power of 2. All right. So it doesn't multiple. It is not multiplied to any number that is smaller than it. All right. So which means it could potentially save a lot of time. Now let's look at the pseudocode. This is from Professor Anani Levantine in Villanova University, and he wrote such a great book which I studied before. It's called The Analysis of Algorithm, as you can see here. All right. So, all right. What the pseudocode said here is, first we create a list which is for p from 2 to n, do ap equals to p. So we just put every number into that array. Then we try to create a second folder, which we try to traverse traverse the list, but we only traverse the essential length of the list, which is from 2 to the lower boundary of square m. And if that number is already being 0, which we have seen before, for example, number 4, we try to delete the multiple of number 4, but actually we have already deleted because it is multiple of 2. So in that case, the if loop is not true, so it will just end and enter the next round of the for loop. But if that is true in the case of 2 and 3, we have another number, it's j, which equals to the square, of that number. As you can see, we are not using the multiple of that number, but we start with the square of that number. And if that number is, then we write a while loop. So if j, which is the number we try to delete, is smaller than the upper boundary of the array, we delete it. So we set it to 0, and then we continue plussing p. All right, which is the number we are assuming at this point, which could be 2 or 3. As long as it is not bigger than n, the while loop can continue and we can delete it. But if it is bigger than n, then the while loop just is aborted, and then coming back to the for loop to move on to the next number. So yeah, again, I try to make the point clear. And the best part of this algorithm is we start with the square of that number instead of the multiple of that number, which saves us a lot of times. That's it. Thank you very much. How do I stop sharing? And we